Hey boys and girls, welcome back. It's Teacher Joseph. Today is Monday, October 26, 2020. Depending on when you watch this video, we will be continuing with the topic of spatial reasoning. This is our last week of that topic. And I think it's important, boys and girls, that we not only congratulate the students who were able to do the investigation, but also look at the specific examples so that you guys are understanding how to do and understand this topic. So again, you were supposed to look at the link for the Jamboard. This was your link, 6A and 6B. Okay. And we had some really cool topics. Like, I am really, truly impressed by a lot of students that were able to really develop this topic. For example, Carlos and Maria Angel chose symmetry. They'll be talking about that this week. Isaac chose pie charts, understanding that topic a little bit better. Eric and Ana Laura chose solid shapes and what they are, examples in real life. Isabella and Sebastian chose congruency and non-congruency, what it means, what it doesn't mean, some examples. Stephanie chose irregular polygons. And then in 6B, we had Naomi and Lucia, who were able to choose a topic on solid shapes in real life. Gabriel chose translational symmetry. Fabian and Diego chose nets and what they look like, examples. Lionel chose polyhedrons, what they are, some examples. And Mario and Sulene chose area and perimeter of different shapes. And actually, that's what we're going to be going and transitioning to today, because we need to go into more depth on what is circumference, which is the perimeter of a circle. When we look at the perimeter of a circle, we need to understand diameter, radius, and a whole bunch of other concepts that relate to circles. So let's take a look at that formula. The formula for circumference is pi times diameter. What is pi? Well, pi is a number that is a mathematical constant. Okay, it's divided as the ratio of a circle's circumference to its diameter. So it's actually related to the diameter and the circumference in a very specific way. It's a very specific ratio. If we look at the formula for circumference, we can take pi times the diameter, or we can take 2 times pi times the radius. I'm sorry. So either one of those formulas will work just fine. Okay. So let's say, for example, we have this radius, which is half of the diameter. Okay, we can take that times 2 and then times pi to find the whole circumference around the entire circle. Sorry about the beeping in the background. This radius right here, as you can see, is going up and up. Okay, so this circle is first circle, second circle, third circle, fourth circle. All of those circles have a radius that is different. Okay, the radius goes up as the circumference goes up. So this circumference is small and the radius is small. The circumference is big and the radius is also big. Okay, we need to understand that those are proportions, those are ratios. So let's do an example. If the diameter of the circle is 30 centimeters, what would the circumference be? Well, we know that the diameter is a direct relationship. It has a direct relationship with the circumference. So the diameter is 30 centimeters. We need to take 30 centimeters times pi to find the circumference. So if I do that on the calculator, for example, 3.14 is pi times 30 equals 94.2 centimeters is going to be our circumference. What if the radius is 4 meters? What is the circumference? Well, the radius, boys and girls, is just half of the diameter. So we can take our formula and we can multiply 4 times 2, which equals 8, and then multiply that by 3.14, in other words, pi, and come up with our circumference. So you can see 3.14 times our, that's actually not correct. That's not correct. If we did that correctly on the screen, we would take our diameter, which is 8 times 3.14 equals 25 and 12 tenths is supposed to be the correct answer as our circumference, meters. Don't forget your label for that problem. So let's continue with another problem. All right. So now that we're understanding this formula to find the circumference of a circle, we also can use pi as 22/7. That's the same thing. If you divide 22 divided by 7, it's going to come up with approximately 3 and 14/100ths. Okay, so let's do another example. If the diameter of a circle is 50 centimeters, what is the circumference? Well, use pi, 3.14, or 22/7 to find your circumference. I'm going to take 50 times pi. I can use 22/7 to come up with 3 1/4. So I'm going to take 50 times 3.14, and that's going to give me 157.14. And there's all these numbers at the end, but I'm going to round that to the nearest tenths place or the hundredths place to find an easier number to understand. So it's approximately 157 centimeters is the circumference. Okay, as you notice, as the diameter gets larger, the circumference gets larger. Okay, so diameter is 2 centimeters, for example. The circumference is going to be 6.28 centimeters. If the diameter is 4 centimeters, then the circumference is going to be larger, 12.56 centimeters. Okay, so the diameter goes up, the circumference goes up. The diameter goes down, the circumference goes down. So let's actually see if we can fill in some of these blanks. Let's read this together. It says, the blank and the diameter are always in equal proportion, or a blank, with each other. This relationship is always the same. Whenever we blank the circumference by the diameter, we will always get 3.14. We call this number pi, and we represent it with the blank. Pi is actually a blank that is infinitely long. It has no end. We usually round it to 3.14 to make calculations blank. So I just want to call your attention to these words, same and same. The relationship is the same between the diameter and the circumference, okay? And we have to understand that the circumference and the diameter are always in equal proportion, or they're a ratio, right? They're a relationship with one another. This relationship is the same. Whether we divide the circumference by the diameter, we will always get 3.14. We will call this number pi, and we will represent it with the symbol pi. Right here, you can see the symbol. Pi is actually a decimal that is infinitely long. It has no end. We usually round it to 3.14 to make calculations easier. So here we have the diameter, and it's related to the circumference in a very, very special way. If we have, for example, these diameters, okay, we have 9 as our ratio, we can just multiply that by 2 to get our diameter. 9 times 2 is 18. Or we could divide. 18 divided by 2 equals 9, okay? So let's just say, for example, we have a whole bunch of diameters and circumference that are put on a table. Okay, so we have a CD, we have a box lid, we have a frisbee, a bowl, a key ring, all these kinds of things are circular. According to the data table, circular objects, which has the largest perimeter, or the largest circumference? Which has the smallest circumference? Well, obviously, 63 is the largest, right? The frisbee has the largest circumference, and the smallest one would be the key ring. Okay, they're all in centimeters, so the 6 is the smallest number. If we look at a semicircle, boys and girls, it's also important that we understand the formula for a semicircle. It's pretty much the same formula, except we divide by 2 because it's half of a circle. So we would take pi times the diameter divided by 2. Okay, let's do an example. So what is the correct circumference of a semicircle if the radius is 5 centimeters? Well, we would take pi times the diameter divided by 2, and then we have to actually add the diameter again. Okay, so we're dividing by 2 because it's a half circle, and then we're going to add that diameter one more time. So we would take circumference equals pi times 10 divided by 2 plus 10. Okay, because, for example, remember, the radius was 5 times 2 is 10. So 10 divided by 2 plus 10 equals what? Let's do that one together. All right, so I'm going to take 10 divided by 2 is 5. All right, so 5 and then plus 10, you can do that in your head, obviously, is 15. So 15 centimeters would be my circumference. All right, let's do another problem. This time we're going to look at a quadrant. A quadrant is 1/4 of a circle. So it's not a full, it's not a half, it's 1/4. So what are we going to do to change the formula for a quadrant? Well, we need to divide this time by 4. So take your diameter, divide that by 4 because it's 1/4 of a circle, and then you're going to add your diameter again to find your circumference. So let's do that. If we have, for example, our diameter could be 10. Let's just do an example right here. Let's say our diameter is 10 meters. Okay, I'm going to take my circumference is equal normally to pi times my diameter. This time we're going to need to divide by 4 because it's a semicircle. Okay, and then we're going to have to add the diameter one more time. So my diameter is 10, pi times 10, and then we're going to divide by 4, and then we're going to add our diameter one more time. So do that. We have pi 3.14 times 10 equals 31.4 divided by 4 equals 7.85. Now we're going to add our diameter one more time, which is 10, and 17.85 is going to be our circumference. So we'll learn more about that, I think, later on. It's just one way to understand the circumference of circles, and then also kind of very briefly expose you to both quadrants and semicircles. So thanks for watching, boys and girls. I hope that your presentations go really well. I know that you guys have spent a lot of time on those presentations, and I can't wait to hear about the progress that you made, and we'll talk to you guys soon. See you later.